Hello everyone, welcome back to my channel. Today we'll discuss the histology of urinary bladder. So urinary bladder is also similar to the ureter, but it's a bag-like structure. So it is also covered by a mucus and the muscle. Ureter was a tubular structure, bladder is a bag-like structure. So the same lining epithelium we have, the same layers, the basic three layers. The one is the mucosal layer, almost similar to the ureter, but here it doesn't have, we're not showing the lumen because it's like a bag. So we'll show the folds because we have in empty bladder lot of mucosal folds. So we'll show the mucosal folds, the folded basement membrane. Over that we are going to draw the transitional epithelium, which is similar to the ureter. So basal columnar, then 2 to 3 layers of polygonal. Topmost layer is the large cuboidal. This is the empty bladder we are writing. So when the bladder is full or expands, the topmost umbrella-shaped cells will become flattened. So sometimes when bladder is empty, it looks like a cuboidal. When bladder is full, it looks flat. That's why the name transitional epithelium. So we'll write the basal columnar, then polygonal round nucleus. The video is a little hazy, sorry for that. Then polygonal round nucleus, and the topmost layer, the round nucleus. Some of the umbrella shaped cells, you keep 2 nucleus. So this is the empty bladder, which has mucosal folds. That's transitional epithelium. Now we make an outline of the circle. We'll shade everything, and just beneath the mucosa you have a lamina propria, that epithelium. So this bladder has a thick muscle wall. So towards the lower end, we'll just make an outline of where we are going to draw the adventitia. So the whole thickness of the urinary bladder is filled with the muscle. So small amount of connective tissue will draw. That's lamina propria. Later, the main bulk. Here, some book says because it's a sac-like structure, the smooth muscle will run in all direction. They can run in all the direction. There may not be any orientation like circular, longitudinal, inner, outer, and all may not be there. But most of the book says it is inner and outer longitudinal bundles and middle circular or oblique bundle. So we'll go with that. So they have inner and outer longitudinal layer and the middle circular or oblique layers. So most of the sac-like structures in our body, that's a stomach, urinary bladder, gallbladder, which has a capacity to expand and contract, the smooth muscle will be running in all the direction. Basically, when they contract, they have to squeeze the bag and push the content outwards. So the arrangement of smooth muscles may not be in uniform direction. So it can run in any direction. For study purpose, and most of the book will follow. So it is inner and outer longitudinal bundles, which is the bundle of smooth muscles with cut sections of the smooth muscles. Here we have to go right centrally placed round nucleus because it's a longitudinal section. The main bulk is the smooth muscles. Okay, don't draw transitional epithelium only big and muscle small. So epithelium is a part of it. The main bulk is smooth muscle. Keep some blue dots in the lamina propria also. It shows the nuclei of the fibroblast and also some lymphocytes. So here I drew first longitudinal bundles. The middle gap I'm going to draw the circular smooth muscle. Now we'll draw the middle circular smooth muscle. It can be oblique sections of it. Same way, the tapering end and middle bulge because of the nuclei. Don't leave too much of gap between individual smooth muscle cells. They'll be connected to one another by cell junctions, so there won't be much gap between them. It will be nanometer gap. Now keep the flat nucleus, oval, horizontally oval nucleus where there is a bulge of the cell. We'll also show some blood vessels which supplies the muscle layer in between. The outermost layer is the adventitia or the serosa. So this is the label diagram. Thank you for watching.